This is Unit 7, Section 6 video. We are going to go over today, our objective is to use the trigonometric ratios to find angle measures in right triangles and to solve real-world problems. We're going to solve for all the parts, missing parts of some triangles today. So if you know the sine, cosine, or tangent of an acute angle measure, you can use the inverse trigonometric functions to find the measure of the angle. So when we talk about inverses on y'all's calculator, I'm going to show you in a minute where you can find those inverses, but you got the inverse of sine that allows you to find the measure of an angle. The inverse of cosine allows you to find the measure of an angle, and the inverse of tangent that allows you to find a measure of an angle. Now, when we use sine, cosine, and tangent in the past, we've been doing that to find sides. So the real question is, are you trying to find a side or are you trying to find an angle? When you're trying to find a side, you use sine, cosine, or tangent. However, when you're trying to find an angle, you use the inverses of those ratios. So I'm going to show you on the calculator where these ratios are. So if you look here, we've got sine here, cosine here, and tangent here. And above them, we have the inverse sine, sine to the -1, cosine to the -1, and tangent to the -1. Now, in your notes, it's asking us to find the inverse cosine of 0.87. So we're going to push second here, and then we're going to push the cosine button. That gives us second cosine. You'll notice up here it says cosine to the -1. We're going to go ahead and put 0.87 in there, and then we're going to push enter. It's going to then tell us that this angle is 29.5 degrees. Let's go on and do the next one. On your paper it says sine to the -1, so we're going to do second sine again, and we're going to put that value in there, 0.85, 0.85, push enter again. And this one is 58.2 degrees. Again, remember, we're solving for angles here when we're using inverses. So our third one on here is tangent. So we're going to go second, tangent, and we're going to push 0.71, and we're going to click enter again. So the measure of this angle was 35.4 degrees. So now you need to go ahead and do the next three and then come back to me to check your answer. So put it on pause, come back and check me when you're done. So the next three are tangent, inverse tangent. So again, I'm going to go second tangent of 0.75, and that's 36.9 degrees. Again, remember, we're rounding up. Our next one is cosine, so we're going to go second cosine of 0.05, enter. That gives us 87.1 degrees. And our last one is going to be second sine of 0.67, enter. That gives us 42.1 degrees as well. So again, just to double check our 6 answers, we had, if we rounded to the nearest degree, it's 30 degrees here, 58 degrees there, 35 degrees there. In most cases, you're going to do it to the 10th. So that's why I did it that way the first time. Here again, it says round to the nearest degree, 37 degrees, 87 degrees, and 42 degrees. So now we're going to go on to example 2. And before we do that, let's talk about this. Using the given measures to find the unknown angle measures or side lengths of a triangle is known as solving a triangle. To solve a right triangle, you need to know 2 side lengths or 1 side length and an acute angle measure. So there are some things that you need to know to be able to solve these triangles. So let's look at this one. So right now we have 2 sides, but we don't have either one of the acute angles. So first thing we can do to solve for the unknown side is to go ahead and use Pythagorean's theorem. So in this case, this would be H. If we were actually, so then ST and SR would be A and B. So if we went ahead and went in here and solved for this, so we do 5.7 squared is equal to 5 squared plus ST squared. And when we do that and square the parts, we're going to actually square 5.7 and 5, and we're going to subtract 25 from whatever 5.7 squared was, and that gets us the square root of 7.49, which is 2.74. So that means this side right here now is 2.74. Now that means we could use any ratio because we have all three sides to find the angle, one of the angles. So we're going to go ahead and use cosine, and we're going to use the two that we had, and I like to always use the two that we had just in case I make an error. So in this one we do the inverse cosine. Now what did we use cosine? Because we're looking for angle R here. So if this is the angle we're looking for, then this is adjacent and that's hypotenuse. So that's the inverse cosine of 5 over 5.7, and when we do that it gets us 28.7 degrees. Now if we want to find the third angle, this angle down here, then we just have to subtract that 28.7 from 90. 90 minus 28.7 is, let me move this thing down here, maybe if I can get it to move. Okay, there we go. 90 minus 28.7 is 61.3 degrees. Okay, so our next method for doing this is to just use sine and cosine. So here again we found the cosine of the angle. And we can then subtract that again from 90 degrees and get 61.3, and then we can use a ratio to find the third side. So in this case we did the sine of r is equal to opposite over hypotenuse. So the sine of r, we know what r is now. We found that angle measure, so we can plug it in. And then we can solve for the missing side. So we did ST is equal to 5.7 sine of 28.7. And then that gives us that side was 2.74. So again, there's more than one way to solve this, and we can use whichever method we are more comfortable with. So up here, so go ahead and do this problem and see if you can tell me how you get the third side. So now I went ahead and set this problem up. We don't have the hypotenuse. We do have the two sides though. So we have A and B. So we're going to do 8.2 squared plus 4 squared. That gets us 67.24 plus 16. We're going to add those two together. Then we're going to take the square root of 83.24, and that gets us 9.12 for FH. Once we have FH, we really could use any ratio to solve for F and H. So we're going to go ahead and solve for F. So we're going to do the inverse tangent of the sides that we were originally given. I always, like I said, I like to do this because that way if I made an error up here, that error is not going to play into the next part of the problem. So then this angle F is 26, so to find angle H, we are going to subtract 26 from 90, and that gets us 64. If we use our method 2, again, first part of this is going to be the same, finding that angle, subtracting it from 90. Now, if we want to use a ratio, if we want to use the ratio that's here to find the third side, we're going to use one of these two angles that we did. So up here, again, I'm going to do the sine of 26. So we're looking for FH. So 26 was the measure of F. So sine is opposite over hypotenuse. We're solving for the hypotenuse. So we're going to do 4 over the sine of 26, and that's 9.12. So again, doesn't matter which method you use, both will give you the same answer. So now this one, we're going to go ahead and talk through this one and solve it. So we do have one of the angles here this time, so we can find this third angle by just subtracting that from 90. So we can do that first. So we know this angle is 32 up here. Now what we need to do is find two more sides. So we can use the tangent ratio if we want to go ahead and find EF, or we could use the sine ratio if we want to find, if we want to do 14 over the hypotenuse. So we went ahead and did tangent because we're going to find EF first. So when we do that, again, we're going to do the tan of 32 is equal to EF over 14. We end up multiplying 14 times the tan of 32, so that gives us 8.75. Now at this point, again, we could use a ratio, or we could use the Pythagorean theorem to solve, because we now have the two sides and we can solve for the hypotenuse. So if we use Pythagorean's theorem, we would do that the hypotenuse squared is equal to the two sides squared. Add that together after we square them, and we get that DF is 16.51. Go ahead and do this check it out example and then come back to me. So here again, if we have the 53, we could subtract it from 90 to get the other angle. That would be 37. If we use what we have, which again, I told you guys before that that's what I like to do. So if we look at this side, it's opposite. And if we're looking for AC first, then that's adjacent. So that's the tangent ratio. So the tan of 53 is equal to 10 over AC. And then we're going to, again, switch these whenever we have a variable on the bottom and we have a ratio, the tangent sign or cosine on the left, we swap them. So then we're going to divide the 10 by the tan 53, and that gets us 7.54 for this side down here. Then we have our A side and our B side, and we can solve for our C side again using Pythagorean's theorem. So that's 7.54 squared plus 10 squared. We take that, add them together, take the square root of it. It gets us 12.52 for AB. All right, now we're going to start talking about grades now. When we talk about grades on a road, that percentage, 7%, we need to recall is 7 over 100. Any percent is a number over 100. So it asks us to find what the actual angle is here. So we're going to change the percent to a fraction first. Now, after we do that, then we can talk about what does this look like. So we're going to draw this right triangle. So that means our distance horizontally was 100 feet. Our vertical distance was 7 feet. So they're asking us to find this angle down here at A. So this angle down here is what we're looking for, the angle of elevation. So as we look at this, we can then say that this is our opposite and this is our adjacent. So if we have opposite and we have adjacent, then we know that that's our tangent ratio. So to find the angle, we do the inverse tan of 7 over 100. So that's what we're going to do. And when we do that in the calculator, we get that this angle down here was 4 degrees. So our check it out example is similar, a little bit different. It says Baldwin State in Dunedin, New Zealand is the steepest street in the world. It has a grade of 38%. So again, we're going to find the angle to the nearest degree. So we're going to change this percent to a decimal. This is going to be our horizontal distance, and the 38 is going to be our vertical distance. So again, when we set up this problem, we're finding this angle down here again. So that's again the opposite and the adjacent. So we're going to do the inverse tangent of 38 over 100, and that's going to give us our angle. And this angle is 21 degrees.